Okay. Here's an example of a rational function. And x plus 4 divided by x minus 5. What we want to be able to do is graph this thing. So what we can do is sort of action. Okay. Can you tell where this function is going to be 0? What number could we put in for 0? You can show me with your fingers. Maybe one hand, maybe another hand for negative sign if you do one. What it tell me? Okay, go. That's it. Well, we can set the expression for r of x equal to 0. So we say r of x is 0 if and only if x plus 4 over x minus 5 is 0. Multiply both sides by x minus 5. Get this. This x minus 5 divided by this x minus 5, leaving us x plus 4. And part of the x minus 5 times 0 is just 0, so x equals negative 4. Now you can also reason this out. But we know that when x equals negative 4 now, r of x is 0, so we have a point negative 4 is 0 on the graph. Now, that's the only 0 of the function. This is therefore the only point that the graph can, the only point at which the graph can pass through the x-axis. Can't go through the x-axis for any other value. Now, you want to think about the domain of this function. Is there any real number that's not in the domain of this function? If you see one, hold up the number of figures you think might represent that. Okay. What see? Well, the domain. Denominator can't be 0. There is 0 if x minus 5 equals 0. X equals 5. Okay, so here's where x equals 5. And no point on the graph lies above or below 0.50, the point where x equals 5 on the x-axis, can be part of the graph. So we can't have a point x is 5. Now we can say the domain is -75 to unit 5 infinity. Everything to the left and everything to the right of this vertical line. I'm going to say no point on the dotted line corresponds to a point on the graph. Of R of X. So the graph of R of X is all to the left of X equals 5 or to the right of X equals 5. Does not include the line X equals 5. Now, what about if X is a really big positive number? You want to see what happens if we go way out on the X-axis. X is a very large positive number. What can you say about X plus 4 over X minus 5? Well, if X is just a million, is 1,000,004 pretty close to, got 1,000,000, add 4. And then you got 1,000,000 here, subtract 5. Is there much difference between what you have? 1,000,000 plus 4 and 1,000,000 minus 5? No, they're practically the same. If you divide 1,000,004 by 999,995, you're going to get something close to what? It'll be about like dividing 1,000,000 by 1,000,000, isn't it? You divide 1,000,000 by 1,000,000, what do you get? Okay. So if X is 1,000,000, this is pretty close to 1, isn't it? If X is negative 1,000,000, well, you're going to get something pretty close to negative 1,000,000 here, pretty close to negative 1,000,000 here, aren't you? So very large X plus 4 and X minus 5 are pretty indistinguishable. So when you divide them, you're going to get something close to 1. So let's just say that here's the line Y equals 1. Way out there and way out here, the graph is going to be close to this line. So that large X R of X is close to 1. We're going to say that the line Y equals 1 is a horizontal asymptote. Then whatever else the line does, it approaches this line as you go this way, and it approaches this line as you go that way. Now, you never do get exactly 1 because any number plus 4 is different than that number minus 5. You're going to have different numbers in the numerator and the denominator. But the bigger the number, the closer that fraction is going to be to 1. What's the y-intercept? Y-intercept is what you get when x is 0, obviously. You get 4/5, negative 4/5. And put in 0 for x, you're left with a 4 over negative 5, that's negative 4/5. So your y-intercept is down here. Now, as you approach x equals 5, the numerator is close to what? If x is close to 5, the numerator is close to 9, isn't it? If x is 5, the numerator is 9. You can't let x equal 5, of course, because that would make the denominator 0, and you can't divide by 0. If x is close to 5, what do you say about x minus 5? Well, you might guess here it's small. X is 4.99. 4.99 minus 5 is 0.01, right? If x is 4.99999, x minus 5 is negative 0.0000001, right? Gets smaller and smaller. Now, what happens when you divide a number that's really small into a number that's close to 9? Well, 0.01, you go into 9. You can count to 9 by 0.01. 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.1. And then you got to go through the whole thing again to get to 0.2. You'd have to count 100.01 just to get up to 1. And you got to count all the way to 900. Okay? So 0.01 goes into 900 times. And x hasn't really even started getting real close to 5 yet. That could be 0.0001. In which case, you'd have 900,000. Okay? Okay. Anyhow, by making x close enough to 5, this fraction gets as big as you like. So r of x approaches infinity, or negative infinity, as x approaches 5. Okay. Now, if x is less than 5, is this fraction positive or negative? If x is less than 5, is x minus 5 more than positive or is it negative? Negative. It's just subtract a bigger number from smaller. You're going to get a negative. So as x approaches 5, from this side, where all the numbers are less than 5, this fraction is going to approach negative infinity. So I can say, write it up here. Okay, the way I've written is r of x approaches infinity as x approaches negative 5. And I've got a minus sign here. I should put it with a positive of 5 to make sure. Okay. As x approaches negative 5 minus, meaning as x approaches negative 5 from numbers less than negative 5, from the negative side. So as we approach x equals 5 from the negative side, r of x approaches negative infinity. So already we know something about this graph. It's going to approach this line as an asymptote. It's going to approach this line as an asymptote. So it's going to look like this. I kind of missed those points. Started off right. Get the idea. It goes through this point, it's on this, from this point. It never reaches this point, but it gets closer and closer and closer. No matter how close you want to get, you can get there if you go down far. So that's what's going on here. Over here, just for large X, R X is close to 1. Y is 1, the horizontal axis. Then on the other side, if X is a little more than 5, X minus 5 is positive, but it can be really tiny. Closer X is to 5 on the other side, the bigger the result is going to be. It's going to be positive because you got a positive number there. So over here, that's going to look like this. It's going to have an asymptote to the line X equals 5 and to the line Y equals 1. And I can say that I have a lot of room here, so you can hear the board, but as you read that, as X approaches 5 from above, the positive side, or X approaches infinity. So we get this. And then, of course, the line Y equals 1 is a horizontal asymptote. In general, when you have a rational function, you have a polynomial on top and a polynomial on the bottom. That's what a rational function is. This is the simplest type of rational function. Well, maybe not quite the simplest, but it's a linear function divided by a linear function. You can easily find the zeros of any linear function. The zero of the numerator is going to make the whole fraction 0, so that's going to give you an x-intercept. A 0 in the denominator, as long as the numerator is also 0, is going to give you a point that's not in the domain, the next value that's not in the domain, and that's going to give you a vertical line, which the graph is up on. Okay. And that vertical line is going to be an asymptote. The denominator 0 and the numerator. Okay, let me do another example.